Okay, so let us start with the module number 3. We will be going question by question. So first question you can write down, that is a natural response of RL and RC circuit. So in exam also this kind of question can be asked, that is discuss about the natural response and step response of RL and RC circuit. So I'm having a document, but this document actually was generated for lab purpose. I will do one thing. I will write some 3-4 pages handwritten, and that I will upload. So today I will upload this document only, what is printed. But for writing in the exam, that question may be asked. Discuss about the RL response and RC response, or natural response and step response for RL and RC circuit. So two circuit, two response. That means there are total 4 responses. So first we have to understand what is meant by natural response and what is meant by step response. Circuit is given to you. Can you tell me? Just look at the top circuit. So below equivalent circuit is there. Don't look at that. Top circuit. Can you tell me what is the circuit and what is the order? So this is transient kind of thing is there. Switch is closed at t is equal to 0. So assume that switch is just now
Sir,
closed.
first
So
order.
whenever you are, hello,
First order,
yeah,
sir.
it is a first order. And Rutik, is it understood why this is first order?
Yes, sir.
Because there is only one energy storing element. Resistance does not store energy, so only one inductor is there. So I can take inductive current as the output parameter, and very easily you can find out what is the transfer function of this. And Vs, any guess what is Vs? So there can be two Vs. अभी तुम्हारे पास पेन एंड पेपर है तो लिख के रखो. If I am giving Vs as impulse input, now I think you know what is impulse input. You have done signals and systems. So it is like the upward arrow at t is equal to 0. So that is the impulse input. So if I am giving the impulse input to the circuit, then whatever response I am getting for the circuit current, it is called as impulse response. Now what is the response you are talking about here? You are talking about the circuit current. Okay, so response can be voltage, response can be current. Generally for RL circuit, we are taking that circuit current is the output parameter. Somebody says, sir, I want to take VL. No problem, you can take VL, because VL is equal to L into di by dt. So for RL circuit, generally we take IL as the output parameter. For RC circuit, so instead of L, if I give you C, can you tell me what is the circuit order? Instead of L, if I connect a capacitor there, what would be the order of the circuit in that case?
Sir, 2.
नहीं, आई एम नॉट कनेक्टिंग L, आई एम ओनली कनेक्टिंग C. It's RC. L के जगह पे C लगाया.
Then first
Then
order,
what
sir.
would be? Then again first order. Rutik, I think it is understood, right? Instead of L, I am removing the L inductor. I am removing, and I'm connecting a capacitor there in the same circuit. So it's a one resistor, one capacitor circuit. So what is the order of the circuit? Rutik, please respond.
Sir, one, sir.
It will be one, right? So this is understood. So two circuits you have understood. The same thing what is shown here. कभी हम L लगाएंगे, कभी हम C लगाएंगे. So resistance is constant, and resistance value, that is a very important thing. If you are connecting a capacitor, and if you are connecting suppose Vs you have connected a step. Step means suppose you have connected a 5 volt DC. So that is called as 5 into unit step. So you have connected a 5 volt DC. The switch has to be closed at t is equal to 0, and R and C. Instead of L, you have to assume C. Okay. Then the capacitor will get charged, and final voltage across the capacitor will be 5 volt, because you have connected input as 5 into unit step, 5 of ut. So finally you will be finding that capacitor is charging up to 5 volt, but whether the capacitor will charge very fast or the capacitor will charge very slow, this is decided by the resistance values. Mobile charger, have you seen? Some charger charges very fast. Within 30 minutes your charging is full, and some charger charges very slow, and it takes almost 1 hour or 2 hours to charge your battery to the extent. Who decides that? Any idea? How is it decided? The same mobile, to different charger. First charger charges your mobile from 0 to 100% within 15 minutes or within half an hour. Second charger, it takes almost 1 hour to charge your battery to the full. Okay, so what decides the fast and slow charging of the mobile? Mobile is same. So mobile is like the capacitor here, which is connected at the load. So what decides the charging time? Any idea? Vinit? Vinay, any idea?
The time constant.
Time constant, correct. What is deciding the time constant? C is constant, so
R
it is the R.
RC.
Okay, so if resistance value is very less, if resistance is 0, as soon as you connect the supply Vs, first the capacitor will charge to 100%. But that cannot happen, because in that case a huge surge of current will come to the capacitor. Huge surge voltage also will be applied to the capacitor, and capacitor might burnt. Okay, because capacitor always tries to, there's a very important line I am repeating, ये लिख के रखो. Capacitor always tries to resist the rate of change of voltage. So if there is a something, if in the very basic fundamentals of electronics, so if there is a very huge rate of change of voltage, वो जो सर्ज अरेस्टर वगैरह रहता है, ओके, हम लोग इसमें लगाते हैं ना, in our home at desktop, okay, we connect some kind of surge arrestor and all those things. So what is there? There's a very big capacitor there. So capacitor always tries to resist the very big rate of change of voltage, sudden surge of voltage, that is actually resisted by capacitor. Sudden change in rate of current, okay, so that is actually arrested by inductor. So inductor does not allow current to vary very fast. Capacitor does not allow to the voltage to vary very fast. So ये दो fundamental याद रखना. So जहाँ पे तुमको current kind of constant चाहिए, very fast rate of change of current you don't need. There you have to adjust the value of the inductor, बड़ा value accordingly. Okay, so here you have understood what is the order of this circuit. The order of the circuit is 1. Now what is the type of inputs? So this Vs input can be impulse. Rutik, you know what is impulse input?
Not exactly, sir.
एक हम लोग ऐसा ड्रॉ करते हैं, x एक्सिस y एक्सिस, ठीक है, y एक्सिस जहाँ पे x एक्सिस को कट करता है, that point is t is equal to 0. Can you understand that?
Yes, sir.
ओके, सो वहां से एक अपवर्ड एरो ड्रॉ करते हैं, एक लाइन एकदम वाई एक्सिस पे, ऐसा ऐसा सिग्नल कभी देखा? इंपल्स t is equal to 0, at t is equal to 0 you are applying 1. So what is step? Step is हम लोग एक पैरेलल लाइन ड्रॉ करते हैं. Okay, so that is DC, that is actually called as DC, that is called as unit step input. But impulse is at t is equal to 0, you are drawing an upward arrow. So I will show you next day, I will show you. So that is actually a upward arrow, that is the impulse input. So huge amount of voltage or current applied only at a single time, t is equal to 0, that is called as impulse. Like hitting a cricket ball, what is the contact time between bat and ball? What is the contact time between bat and ball? Is it very big? बहुत टाइम से बॉल बैट में लग के रहता है, और it just contact time is very less.
Very less, sir. Split second sort of thing.
Very less. I suppose I'm hitting a punch in your face. Is the contact time, हम ऐसा पंच मार के ऐसा रखते हैं उधर, और हम लोग ऐसा मार के निकाल लेते हैं. Okay, so contact time is very less, but whenever that contact time is there, in that very small time, huge amount of force is transferred from the source to the destination. So for very small time, t is equal to 0, very fast, small, very contact time, a huge amount of force is applied from the source to the load. That is actually a impulse input. I will draw and I will show it to you. So when this Vs is actually the impulse input, then whatever response you are getting for the circuits, so current kaise dikhte hai, that is actually called as impulse response. Or next input is step. Step means a DC. If I am giving a 2 volt DC, this is called as a 2 into unit step. So if I am giving RL circuit, what will be the circuit current? If I am giving a step input voltage to the RL circuit, what will be the circuit voltage or circuit current? If I am giving an impulse input to RC circuit, if I am giving a step input to the RC circuit, what will be the voltage? So this is the thing we are going to study, and these are first order circuits. Next day we will do second order circuit. Okay, let us think of what is meant by, so this is what is the background. Now there are two responses. One is called as natural response, another is called as step response. Okay, what is meant by natural response? Natural response is like, in this circuit, is there a supply input? Yes or no, just tell me. In the above circuit, is there a supply input? It is there or it is not there? Just yes or no. It is there, right? Vs is there. So supply is like the food, what we eat. And this R and L, this is actually the system. So this can be the human body. Just I'm giving you an analogy. So Vs is the food and RL, that is the system, that is nothing but human body. Continuously you are giving the food, continuously you are connecting the Vs, and there will be a continuous current. Okay, so as long as Vs is there, current will be there. This is very easily understood. Now what happens is, that is actually the step input. I am connecting a DC to the circuit and continuously I am getting some kind of current in the inductor. अभी हम क्या करते हैं, I am going to connect a impulse. Okay, where is the impulse? Impulse is occurring only at t is equal to 0. Okay, so at t is equal to 0, there is an upward arrow we show. Okay, so only at t is equal to 0 the input is there. So what we do in this case is, at for certain amount of time, so I am first explaining what is meant by natural response. For certain amount of time at the starting, we are connecting the input to the circuit. That means the switch is closed. Okay, so for certain amount of time this switch is closed and the input is connected to the circuit. So what is happening is, there is a current building up in the circuit. So through the resistor, through the inductor, some current is flowing and there is a current build up in the circuit. Any doubt in this, whatever I am saying up till now?
No, sir.
This is understood, right? So I am connected the voltage, the switch is closed and some current is flowing through the circuit, R and L, and it is flowing. उसके बाद हम लोग क्या करता है, suddenly we remove the supply. Suddenly we remove the supply and we connect this R to the ground, and how the circuit will look like then, समझ में आ रहा है? So for certain time in the input, so तुमने एक human को for certain time you are giving him the food. उसके बाद तुम क्या करते हो, आदमी को निकाल के एक रूम में बंद कर देते हो विदाउट एनी फूड. Exactly the same thing we are doing for this circuit. For certain time we are connecting the input to the circuit, and after that certain time वो हम decide करते हैं, maybe 5 seconds, 10 seconds or whatever. And after that suddenly we are doing what is, हम लोग वो input निकाल लेते हैं and we just connect this R to the ground, and we are not connecting any input to the circuit. But previously you had connected some voltage to the circuit, so there was a current build up in the circuit. Now what will happen, the current will very slowly die down. In which fashion the current is dying down, that response is called as natural response. तुम क्या करते हो, एक आदमी को थोड़ा आधा एक दिन खिलाते हो, you are just feeding him, and suddenly what you do is you stop him any food and उसको एक घर में बंद करके रखते हो. What will happen after 15 days? The person will die. Any doubt in this? You have fed him for certain times and after that suddenly you close him in a closed room and you are not giving him any food, you are not giving him any water. What will be the thing? He will completely die after certain days, and that will be a natural death. Slowly the energy in his body will come down, and slowly at one point what will his body will find is to pump the heart, to keep the brain active. Whatever energy is required, that energy will not come in his body because he is not getting any food. So what will happen after 5 days or 10 days? He will automatically die. ये फंडामेंटल समझ में आया?
Yes, sir.
Yes, sir.
ऋतिक अंडरस्टूड. तो पहले कुछ दिन खिलाओ, उसके बाद खाना बंद करके उसको बंद करके रखो. He will die. Die means exponentially his energy will fall and he will die. Exactly the same thing will happen for this circuit also. If it is a RL circuit, for the first sometime you are connecting input to it, then after certain time you are removing the input, and then the circuit looks like, I will show you now, then the circuit looks like this. अभी समझ में आ रहा है? How will the circuit? So L right में होना चाहिए, R left में होना चाहिए. अभी समझ में आ रहा है? Is this circuit having any input? Is this circuit having any input voltage or input current?
No, sir.
No, sir.
No, there is no external input or voltage connected. फिर भी मैं current दिखाया. ऋतिक visible?
Yes.
वो current कहाँ से आया? That current has come because you have connected the supply to it for some time. तो तुम जैसे ही आदमी को घर में बंद कर रहे हो तभी नहीं मरता है, because some current is still flowing in the circuit, some energy is still there in his body, and that energy actually slowly falls down over the period of 5 days, 10 days and all, and after 5 days or 10 days obviously he is going to die. Same thing happens in case of a RL circuit. So for RL circuit it is current, because whenever you are connecting, so previous circuit I had shown you, ये circuit either तुम draw कर लो और तुम्हारे दिमाग में डाल के रखो ये circuit को, that this was the initial circuit. I had connected some voltage, switch was closed. वो switch को जरा सोचो मत, तो switch को short circuit कर दो. Okay, R and C was connected, or maybe RL L was connected. I had shown you I think RL Okay, so R and L was connected, and then after a certain time I'm removing the supply, but by the time the supply was connected there was a current build up in the circuit. Why there is a current build up? Because inductor saves energy. अभी समझ में आ रहा है इंडक्टर सेव्स एनर्जी का कितना बड़ा इंपॉर्टेंस है. इंडक्टर सेव्स एनर्जी मींस इंडक्टर कैन ड्राइव सम करंट, ओके, थ्रू द सर्किट इवन इफ देयर इज नो इनपुट वोल्टेज. तो अभी ये करंट जो है, दिस करंट इज काइंड ऑफ अ कॉल्ड एज अ सर्कुलेटिंग करंट. Okay, so this current will flow through the inductor for certain time. ऐसा घूमता रहेगा, घूमता रहेगा, घूमता रहेगा. Then this current slowly will fall and will come to the rest, and the current will fall in an exponential fashion. And this response is called as a natural response. Why this is called as natural response? Because if the R value is very less, okay, in that case we will be finding that the current will come to the ground. It will take quite a long time. Okay, R value is very less. If R value is very high, then very fast the current will come to the ground. Okay, this will say, and this response is called as a natural response. Now there are two persons. One is you are person A, I am B, I am person B. तो हम दोनों को सेम अमाउंट ऑफ खाना खिलाया जाता है. ओके, सो वी बोथ ईट काइंड ऑफ 200 grams और 300 grams of food at the initial case. तुमको एक घर में बंद करके दिया, मुझे एक घर में बंद करके रख दिया. So maybe I will die in 3 days, maybe you will come to an end after 5 days. Why does it happen? Both are human being. Okay, both ate same amount of food, but एक जन 3 दिन में मर रहा है, एक जन 5 दिन में मर रहा है. Why so? Because the body parameter of these two human beings are different. The heart capacity of these two human beings are different. If there is a very thin fellow, okay, with the same amount of food, he will live for a longer time. If there is a very fat fellow with the same 200 gram amount of food, he will die in 3 days. Because the fat fellow, his heart requires more energy per pumping. Because fat fellow means उसका body में mass ज़्यादा है, उसका body में cells ज़्यादा है. Okay, so more amount of energy is required to pump the energy to the every cell. Okay, so every pump is requiring more energy. तो उसका body में energy wastage ज़्यादा होगा. Okay, and we are not giving him any external food, so he might die in 3 days. But a very thin fellow, okay, his mass is very less, so he might live for 6 or 7 days with the same amount of food. But the death is inevitable. Okay, so if you're not giving any food, automatically his lifespan or his energy will come and die down and it will touch the ground. Is it understandable what is called by natural response?
Yes, sir.
Yes, sir.
Is it understandable? तो ऐसा कोई बुक में लिखा नहीं रहता है, but this is what is happening. So one circuit is there. There are 3 components. कौन सा 3 components? Okay, first one is the input supply, second one is the resistance, and third one is the energy storing element. It can be inductor, it can be capacitor. So I can ask any one of these two in the exam. Okay, draw the RL natural response. So in that case, first you have to tell what is RL circuit. So there is a resistor, there is an inductor, and initially you have to feed some energy. And you have to connect VS. And what is VS? VS is impulse. तो आज मैं तुमको impulse नहीं दिखा सकता. Next day I will show you what is the impulse signal. So मान लो कि that is the input energy. So that impulse you are connecting for a certain time, and after that you are just removing that. So अब इस impulse सोचो मत, just think it's a VS, it's a supply. You are feeding the circuit for a certain time. If it's a RL circuit, then there is a current build up in the circuit. If it's a RC circuit, then there is a voltage build up in the circuit. What is a output parameter for a RL circuit, Vinay? It is inductive current. What is a output parameter for a RC circuit? It is a capacitive voltage. ये दोनों याद रहेगा?
Yes,
Can you
sir.
understand these two, Rutik?
Yes, sir.
What is a RL circuit parameter? एक बार बोलो. It is inductive current. What is RC circuit parameter, output parameter?
Capacitor voltage.
Rutik, understand?
Yes, sir.
So RL circuit, it is current. RC circuit, it is voltage. So RL circuit में current fall होके zero हो जाएगा. RC circuit में capacitor voltage fall होके zero हो जाएगा. And both will fall exponentially. उसका proof वगैरह है, हम proof नहीं देखेंगे. We will just see what is the final result and we will draw the graph for that. Graph भी इसमें दिखाया हुआ है. So first you have to start with that kind of a circuit. There should be a VS, there should be a resistor, there should be an inductor. If it is RL, first order, and you understood what is first order, because resistor does not store energy, inductor stores energy. So RL circuit is a first order. And why natural response? Because we are connecting the input to for the certain time, and then after a certain time we are removing it. We are just checking for inductive circuit how the current falls to zero, whether it is falling very fast, steeply, exponentially, whether it is falling very flat, slowly. But ultimately it has to come to zero. It can be a RC circuit, that is also a first order circuit. We are connecting voltage for a certain time, and after that we are removing it. We are making the circuit like this. So RC circuit का भी नीचे दिखाया हुआ है. I think I will post this diagram and you'll understand. ये RC circuit. Can you understand? This is RC circuit, natural response. Why am I calling this natural response? Because there is no external forcing function connected at this point. Whenever the circuit is drawn like this, how many components you can find out in the circuit? Only two. One is a resistor, one is a capacitor. There is no input connected to the circuit now. Okay, so that's why whatever response you are finding, that is called as a natural response. There is no external forcing function. Okay, and the capacitor voltage also will fall to the zero. Okay, so this is RL response, RL current response, and what is the formula? ये देखो formula दिया हुआ है. Is it visible? IT is equal to I0 into minus RT by L. Is it visible, Rutik? Last line of the previous page. How
Yes,
the
sir.
current will fall to zero? So IT is equal to I0 into e raised to minus 2t. तो RT by L, R by L को मान लो 2. So what is L by R? L by R is called as time constant. ये लिख के रखो. R by L इसमें दिया हुआ है, but that R को हम लोग L के नीचे ले लेते हैं. So one thing, one line you can write down. It is written here in the next page. That is this IT, whatever IT is shown here. This IT actually gives the equation of natural response of RL circuit after the DC source is disconnected from it suddenly. So previously the source was connected, तुमने खाना खिलाया, अभी उसको बंद कर दो. Okay, so the term L by R, okay, the term L by R is called as time constant of RC circuit. So more is the value of R, less will be the value of L by R. Okay, so less is the value of L by R means it will take quite a lot of time for the system to fall to the ground. तो हम दिखाते हैं R का value के साथ how the graph changes. You can see here. So if it is more is the value of R, more is the value of R means you will be finding that suppose e raised to minus L R by L, maybe it is 7. Okay, so in that case it will fall very fast, because I told you, I had shown you this graph, e raised to minus 70 and e raised to minus 2t. E raised to minus 2t will fall flat, it will come to 0, and e raised to minus 70 very fast, it will come to the ground. So more is the value of R, faster will be the fall. Faster will be the fall means system is very fast. Okay, so in that case time constant is smaller, system response is faster. So more is the value of R, system response is faster. So that you will find. So everything is written here. Proof is not in your syllabus. Only one thing you have to understand is for RL circuit, L by R. L by R, what is the unit of L by R? It is called as time constant. It is called as seconds. Okay, L by R unit is seconds. L is in Henry, R is in ohm. So Henry by ohm we are calling as seconds. So this IT equation, whatever was given in the previous page, IT is equal to I0. Any idea what is I0? What is I0 called?
So current and
Transient
condition.
current at the starting. Okay, what is meant by starting? तुमने initially जब whenever you are connecting that input voltage to the whole circuit, at that time there is some current build up in the circuit, and after a certain time suddenly you are cutting the input voltage from the circuit. At that point, whatever is the current flowing to the circuit, that is the initial current. So initially L and R, they are not having any current, okay, because no supply is connected, provided it's a pure inductor and pure resistor, or pure inductor, pure capacitor and a pure resistor. If it is RC circuit, there is no voltage, initial voltage. Then you connect some food, then you connect some supply, and what happens is there is some voltage build up in the capacitor, or there is a current build up in the inductor. Suppose वो current है 3 ampere, okay, or 3 milliampere. When the current reaches to 3 milliampere, suddenly you are cutting the input voltage, because you want to check how fast or how slow that current falls to zero, okay, exponentially. Okay, and that depends on how fast it will fall to zero. That depends on the circuit components, the value of L and R. Okay, and that is actually a time constant. So what we are finding is, more is the value of R, the current will fall faster. Okay, because you are finding that L by R is called as a time constant. More is the value of R, less will be the value of L by R. Okay, so more is the value of R, less will be the value of L by R. In that case, current will fall very fast. So less is the value of time constant, the system will be faster. Okay, so it is written here. All this proof and all these things are not there. You can see this response. Rutik, is this response visible? Three graphs I have shown. Okay, what
Yes,
is
sir.
the top graph? Top graph is called as RL circuit, natural response, inductive current. Can you see this blue graph? It is falling exponentially. I think it is visible. So initially the current was quite high. It was I0. Suppose I0 is equal to 1 ampere. Let's say I am adjusting R and L value in such a way that I0 is equal to 1 ampere. And then as soon as I'm removing the supply and I'm just making R and L parallel, very fast it will come to 0. So this is that exponential fall. Whatever graph I have shown, I is equal to I0 into e raised to minus RT by L, that graph will look like, so exponential graph, exponential e raised to minus t. यहाँ पे देखो it is written, okay, here in this line it is written it is equal to I0 into minus RT by L, I0 e raised to minus t by tau. So ये R को L के नीचे लाना है. So tau for RL circuit is L by R. ये R by L मत लिखो, because tau for inductive circuit is L by R. L by R means inductive by resistance. Okay. So you can see here from the first graph, that is RL circuit natural response, inductive current. So I told you that for RL circuit the parameter is inductive current, and for RC circuit the parameter is capacitive voltage. So only this graph you have to remember, this blue graph, because the characteristic is I is equal to I0 into e raised to minus L by R, or e raised to minus RT by L. I mean, this is a very important graph. Okay, this is a very important graph. So where what I have done is I have made the comparison of three different systems. Smaller is the time constant tau, faster is the decay. Rutik, can you tell me in which case the graph is falling to zero faster? Red graph, blue graph, or black graph? Initial current is 1 ampere. Okay, so in which case current is very fast falling to ground? Red, blue, or black?
Red, sir.
It is understandable. Okay, so red is falling very, so these are three different systems. Okay, तुम L को constant रखो, R को change करते जाओ. Okay, so in which case R is greater? So in the first case जब red है, in this case R is greater, because L by R is smaller. L by R is smaller means the graph will fall to zero very fast. Rutik, understandable?
Yes, sir.
ओके तो ये थोड़ा इनवर्स रिलेशनशिप है, तो इसीलिए थोड़ा समझना चाहिए. व्हेन एवर ग्राफ इज फॉलिंग टू ग्राउंड फर्स्ट, फॉर द फर्स्ट केस रेड वाला, दैट मीन्स दिस इज हैविंग अ स्मॉलर टाइम कांस्टेंट. For any system, smaller time constant means system is going to reach to the output destination fast. Okay, so for the first case red, in this case time constant is less. Time constant is less means for constant L to 1 Henry ले लो, R value will be lesser. So the same thing it is given here. Hence for the highest value of R is for the red graph. ये dark में लिखा हुआ है. Time constant will be lesser, red graph, and system will be faster, keeping the L value constant. And for this black, it is called flatter. It is going to zero almost after 5 seconds. Also it is not going to zero, so maybe at 10 seconds this graph will be equal to zero. So in this case R value is smaller. If R value is smaller, L by R value is higher, time constant is higher, the inductive current is touching the zero value at a higher time distance. So ये जो नीचे line लिखा हुआ है, this you have to read. So system will be faster, keeping L value constant. Here system output will reach, so first case final steady value 0. In the above graph, system response red is fastest as it reaches to final zero value fast. System red is with smallest time constant R. तो टाइम कांस्टेंट इज अ पैरामीटर व्हिच डिसाइड्स. जो चार्जर का एग्जांपल याद रखना, कितना जल्दी तुम आउटपुट रीच कर रहे हो. सो फॉर चार्जर रीचिंग द आउटपुट मींस यू हैव टू चार्ज द बैटरी टू द फुल. ओके, बट फॉर दिस सिस्टम नेचुरल रिस्पांस, रीचिंग आउटपुट मींस हाउ फास्ट यू आर कमिंग टू जीरो. Okay, so this is actually the natural response, and R value bigger means time constant is less and you are falling to zero amplitude very faster. Is this circuit understandable? RC, This is natural response or forced response. What is meant by forced response? Forced response में एक external input रहता है, forcing function जिसको बोलते हैं. Is there any external input to this circuit?
No, sir.
There is no input. Okay, but input we had connected previously. There was an input connected, but now after feeding some voltage to the capacitor through resistor, okay, so capacitors got charged through resistor. Now suddenly we are removing the supply, and we have connected the R and C in parallel, and we are just expecting how fast this capacitor voltage will go to zero. Okay, so in this case, what is the formula? So previous case it was I is equal to I0 into minus RT by L. यहाँ पे ये formula है. Rutik, can you read it? What is the formula? VT का formula जो है, can you read it below?
VT equals to AE.
A exponential raised to minus T divided by RC. Understandable? So what is A? A is you connected the initial voltage, and just the time when you thought of removing that voltage, उस time में capacitor had stored V voltage. So actually A is V0. So that is the initial voltage, and initial voltage will come to zero after certain time. So what is the time constant in this case, Ritik? How much is tau in this case? It is R into C. तो ये एक चीज लिख कर रखो. For RC circuit, time constant is given by R into C. And previous circuit, RL circuit, what was the time constant? It was L by R. So ये दोनों formula as a electronics engineer दिमाग में एकदम fit करके रखना है. Okay, so for RL circuit, time constant is L by R, and for RC circuit, the time constant is R into C. Okay, so what is the relationship between time constant and resistance? For inductive circuit, it is inverse relationship. More is the value of R, less is time constant. In case of RC circuit, what is the relationship? It is direct relationship. More is the value of R, higher is the value of time constant. Vinay, understood?
Yes, sir.
Rutik, understood?
Yes, sir.
So tau for RL circuit, it is 1 by R, because tau is equal to L by R. So resistance and time constant, they are inversely proportional. तो inductive circuit में तुम tau बड़ा R बढ़ा रहे हो, तो तुम्हारा system is becoming faster. But in RC circuit, if you are increasing the value of tau, R, your system is going to be slower. तो अभी देखो, now this is the graph for inductive voltage, capacitive voltage. You can see here RC circuit natural response. This is the capacitive voltage, and this is again exponentially decreasing. And what is the formula? VT is equal to, so Rutik, you had read it very correct. So it was VT is equal to V0. वो सोचो मत, what is the initial voltage? E raised to minus T by RC. ये बहुत important चीज है. What is the time constant? Previous case it was L by R. Now it is RC. So more is the value of R, more will be the time constant. So last graph I will show you. Just give me 1 more minute and it will be done. Just tell me which graph is falling faster, black or red? So this is the voltage graph. Which graph is falling faster, black or red?
Black, sir.
Black.
Black is falling faster. That means उसमें R का value कम है. This much you have to remember. Previously black की जगह पे red था. Red का value ज़्यादा था. So if in case of L by R, the red was having here, red was in the left side. So for LR circuit, if R is more, it will fall faster. For RC circuit, if R is less, it will fall faster. So this is RC natural response with different time constant. Black is having lowest time constant because C value constant hai. So here it is written. Smaller is the value of time constant, faster is the decay. Decay means fall. Okay, as tau is equal to RC. Hence, for smaller value of R or C, time constant will be lesser and the system will be faster. Faster system output will reach to the final or steady state value. What is the steady state value? It is 0. Okay, so initially it is starting from amplitude A or V0 and very fast it is falling to 0. So faster is the system output, it will reach to the final steady state value, 0 value faster. So in this case, lesser is the value of R, the system will reach to 0 amplitude very fast. So whatever we have done today in last in 2 lines, I can give you the gist. For LR circuit, more is the value of resistance, the circuit is faster. In case of RC circuit, less is the value of resistance, system is faster. So we complete here the natural response of RL and RC circuit. बहुत छोटे में बता दिया. I will write or I will edit this graph and document and I will upload. And tomorrow we will start with step response. So step response of RL, RC and RLC. So when we give the input as step input, how the response looks like, that we will do tomorrow. Okay. Thank you for your time. We